Hey.
Hey. What's up?
Morning.
Morning.
Cool. All right, everyone's on.
Great.
Okay. Hi, TA. Or tutor. What's your name?
Oh, she can't hear us.
Oh, I can hear y'all, but I can't see anything yet. Can y'all hear me?
Yes, we can hear you.
Okay, I guess that's
Yeah.
good enough then. Okay, I think it's starting to work. Sorry, I had to press like so many things to say like I accept.
Mm.
Okay.
Quiz 7, right?
Yes.
Okay, good. If that's like the quiz I did, well, that'd be really wrong. Did anybody have any questions off the bat on lesson 7, or do you just want to go into the quiz?
I just had questions on the quiz, but
Yeah, I just had quiz questions.
Yeah, same.
The group reading quiz. Perfect. Let's get it open. I'm gonna minimize the camera for a second so it doesn't look like I'm not looking at you. Which question on the quiz? And the quizzes is together and you're doing the second time together?
Say what? You broke up. Can you repeat that?
Oh, sorry. What are we looking at? Here, I'll type it.
I couldn't hear you.
Yeah, you're breaking up a lot, so it's hard for me to hear you too.
I can kind of hear you.
I'm gonna type. Okay, I'll type. I can't type. Sorry, I'm on the campus's Wi-Fi. That might be why. I'm at the MC.
You're good.
On the quiz first, do y'all want to go over? There was a like that took me a while, so hopefully y'all don't ask that one.
Well, I got 4 and 5 wrong, but I think it's because I wasn't paying close enough attention to the wording of the problems. And then I got 14 wrong. The rest I did okay.
Number 5. Okay. I'll write these down. Number 5. Is there another one?
14. 14 is the actual like equation problem that I got wrong. Other than that, I did fine.
Okay. Number 5 and 14.
Mm-hmm.
Get those specific questions open. Is a little slow and the campus Wi-Fi isn't. But my apartment's Wi-Fi is even worse. So just number 5 and 14?
Yeah, basically, like I got 4 wrong too, but like I said, on 4 and 5, I think I just wasn't reading the questions closely enough.
Okay. Can you read number 5 to me? Because I have all the questions open, but there's no.
Yeah. Which of the following results implies that the spread in X line decreases and the sample size increases. I believe that's mean, right? Sample mean, that sign. But I put normal wait. Well, that's why I got it wrong. I put normal distribution. Now I'm looking at it. I'm like, yeah, that's not it.
I put
And said group meeting quiz. Oh, okay, hold on. I just found it.
In less than 7 group meeting quiz.
No, I got it.
Okay.
The X bar decreases as the sample increases. Go down. So whenever it says something like that, it's kind of like it's a vocabulary and it's just a rule, like a definition of something. And so the central limit theorem.
Yeah, I thought I pushed the central limit theorem, but I did not. So I'm like that. That's why I got it wrong.
So whenever you read the question, right, the normal distribution isn't. The normal distribution is just that it makes the curve like this.
Mm-hmm.
that makes sense.
It looks like the 68, 95, 99, 99.7 rule. That's a standard deviation rule. It doesn't say anything about standard deviations. We can knock that one out. C and D, the central limit theorem, and the law of large numbers. Can y'all hear me so far so well?
Yeah.
Yeah, I can hear you.
Okay. So those are really similar because those are both saying that the more people that you survey, or the more normal it is.
Mm-hmm.
But the difference between them is the central limit theorem is all about shape. Numbers is all about numbers. And X bar, so that's saying the standard deviation, or it's in your specific data. Standard deviation is going to be smaller the more people you survey, and that's the law of large numbers. An example of that, to make that make sense, so I am 5'4", that's how tall I am. It is 6'1", and so the mean height, if I just out of our heights divided by 2, would be like 5'7", 5'8". Would be plus or minus how tall I am, how tall he is.
Mm-hmm.
And more when I record how tall they are, the standard deviation gets smaller because my brother is way taller than me and I'm way shorter than him, just because that's how the genes worked. And also, if I were to tell you the average of me and my brother's height and try to tell you presents this average height because he goes here too, that's not very credible because I only surveyed 2 people. Can y'all hear me?
Yeah, I mean,
Yeah,
you break up a lot, but if I'm focusing, so like if I'm focusing on your voice, it makes sense.
Sorry. Okay, good. And so the more people so if I just took me and my brother's height and told you the average of our heights, that's not super informative because there's only 2 people.
Right.
Every single person in this class, every person in one of my classes, and like in another class's height, and then I averaged it. That's another word for standard deviation. I love that she used the word spread because that's the best way to understand standard deviation. For the more people that you survey or you get data from, the smaller your standard deviation is. You have a lot of in between because most people are going to be average-ish height, outliers of course, but most people are going to be staggered and close together in their height. And so the law of large numbers is telling us that the more people that you survey, your results are going to be, and also the more likely that you get your graph that you can make is going to be pretty normal, and the smaller is. And the central limit theorem is kind of saying the same thing, except for it's just talking about shape. It's saying if you ask 55 people their height, it will make a normal bell curve. Even if the question says, that it is known that the information is low. If you survey, the central limit theorem promises that the more people you survey, your information is going to be just because that's the rule. Numbers is saying the more people you survey, the smaller your standard deviation becomes. People are going to be generally normal. Does that make sense?
Yeah, it does.
So I don't know if that made sense.
No, that makes sense.
That makes sense.
Okay,
Thank
good.
you.
Mhm. That's good.
And the number 4, let's see. What is the probability that the mean of the GPA of 81.3?
Mhm.
So here is the equation. I'll write it and then put it in the camera. So do you recognize this equation? I don't know if it's going to be like mirrored. Does
Yeah.
that
Yeah.
Yeah,
look
that makes
familiar?
sense.
So we're given some information. Oh, okay, so X bar is always the number that's given you in that particular question. X is always the number that's given to you questions when it's like, use this information for the following 3. 3.3 minus 3.5.
Mhm. Is negative 0.2.
Yeah, it's a negative 0.2.
Yeah, we get.
The definition of z-square makes sense?
Yeah.
Yes.
Perfect, y'all are really smart. Okay. What's the, let's see, the standard deviation divided by 9. Okay, so 8.8. I have a crummy simple calculator, so bear with me. 9 equals, then continue, 0.2 divided by that equals, so I got a z-score of negative 2.045 or negative 2.05 if I round it. And I can already tell that my answer is big because my z-score is really small. Oh, normal probability applet. And put my z-score in. And my z-score was negative, so I just go to negative. Doesn't matter. If I put the z-score in the wrong one, it just on the other side anyways. I want anything greater than that. Wait, did I do something wrong? Specific z-score. Let's see. What did y'all get? Like, what steps did y'all take? I want to see what y'all's thinking was.
Well, on 14, because it has a lot of the same numbers as 13, because I got 13 right. And so I'm thinking, because in 13 it says less than 3.3, and then 14 it's greater than 3.3. And so for some reason I wrote down the same answer that I got for 13, I wrote down for 14.
Yeah, that's what I was thinking too. That
Yeah.
it was
Because
the same.
if it's, you know, if you're just on both
But I got both
sides
of
of
them
the
wrong.
chart of the curve, I thought it was supposed to be the same.
Okay, I can totally see what you're saying. I can see your thinking. I really can.
And so that's what I got wrong. I got, well, on 13 I got 0.005, and which was correct.
Mhm.
And then on 14 I got 0.052. So I don't know if I just wrote down or typed in the wrong numbers, because I do that sometimes, or if but I also have that on my paper. It was 0.052. So I'm not sure what I did wrong with 14 compared to 13 that I did correctly.
Okay, so I got this. So the z-score in the long textbook definition is how many standard deviations away it is, right? But the thing about the standard deviation doesn't tell you as much information. Say that me and my brother's average height was like 5'8", and the standard deviation was 4 inches. You don't know if I'm taller, and I told you that I'm 1 standard deviation away. You don't know if I'm 5'4" or if I'm 6'2", because you don't know which way I am. Z-score tells you if you're less than or greater than.
Okay.
You did all the math, and so the z-score tells you if you're less than or greater than, right? Negative or positive.
Right.
0.3, you got 0.005. That you all got that one correct. So if you were to be greater than that, it would be 1 minus that. Does that make sense? So the area, your answer is the area, and your answer cannot be greater than 1, which is what we learned. That was like a definition from the beginning. That's why we learned that first. A probability is between 0 and 1. And if you're less than something, and now you want to be greater than it, you're just doing, you're mirroring it, you're doing the opposite. So it becomes 1 minus that.
Okay.
Okay.
So 1 minus the 0.005, the 0.005.
0.005.
Okay. Huh. It's kind of
Okay, that makes sense.
Yeah. One way I kind of think about it is the probability of your GPA being less than 3.3. That the average is 3.5, right? So like if you're like way less than the average, be low. But if they want to know if you're how much the probability of being greater than 3.3, and we know that the average is 3.5. Like on average, students are already greater than 3.3. So that already tells me my answer has to be pretty big. Which person is greater than the number they ask about, then the answers, and it's even less than the average. I'm rambling. I have a rambling problem.
No, you're doing good.
Yeah, that makes sense.
Okay, good. I even did all the math, and I was like, hold on, something's wrong.
Yeah.
And then it's simpler. That's the previous question. It sounds like clicked. Explanation.
Okay. Well, those
And
were
the
my
normal
questions.
probabilities are going to show up on the test semester. So I'm glad that y'all understand it's going to be the answer every time. It's just sometimes you have an N and sometimes you don't have a sample size. And so understand that y'all are in good shape. Y'all only got 2 wrong. That's awesome.
Well, that was just me. I don't know what what Taylor and Rebecca did. We kind of do it all first separately and then come together and work on it for the second time around. So that was just me. I don't know what everyone else got.
I had questions on 8 and 9. I got them wrong, but then I redid it, so I just wanted to check my answer.
Okay, sorry, the way I have the quiz set up, it doesn't tell me what number is what. Can you read the beginning of number 8?
Yeah. So it's saying, let's see. Random sample of 5 students was selected, and then it gives you the 5
Okay.
numbers, and it says what is the z-score corresponding with the sample mean of the student scores. And this I didn't look up like a couple questions beforehand and see that it actually gave us like mean and a standard deviation, so that's why I didn't get it. But
yeah, you're like, this is not enough information, right?
Yeah. So that one took me forever, but I just redid it. I don't know if Kelly, if you got it right, if 8 is 1.045.
That's super close. The reason why there's more to it though is now you're given a sample size. So you just do one more step, and because I'm pretty sure 1.05 is an answer without the sample size. It was 160, I'm assuming, because of the answer you got. Yeah. Their average, 150.8, that's 9.2. Because let me do the math real quick, because I'm pretty sure that's what you did. Yes, you got the answer, but now you just need to do 8.8 divided by the sample size, and then it tells you the random sample is 5. Hold on. I have a really simple calculator, so 5. And you get the square root of that, it's approximately 6.1. So then 8.8 divided by that, and you can just put it all in. And it's 3.9354 approximately. I'm just doing as many decimals as possible because I'm not rounding all the way yet. And then I do the x bar minus x divided by that answer. Does that make sense?
No, I'm lost at what you're saying.
Here's the formula again. I don't know how much you
What?
can see. See?
Okay, do it one more time.
Okay, here. Let's see. I need to go up or down. Here, so I can read it out loud too.
Okay.
So it's a fraction. The top of the fraction is going to be x bar, and x bar minus x. X bar goes first is because you need to know if it's going to be less than or greater than x, which is your big average that they tell you. The denominator, so you divide that by the standard deviation. Given a sample size, then you have to do standard deviation divided by square root of n. Standard sample size.
Mm-hmm.
Work. So I'll type it in. Because I don't know how to do that. So standard divided by square root of sample size. So it's a big fraction. You did was completely correct, but now you just have to consider the fact that you were given a sample size, and so you just keep going.
Okay.
Correct until sample size. So here's what the formula looks like for this particular question. Let me just boxed it if you can see it. Enough.
Yeah, 1 second. What did you put it over?
8.8 divided by the square root of 5.
Oh, okay, cool. Okay, that makes more sense.
And the reason was the law of large numbers, right? The more people you survey, the standard deviation is, and so this is proving when you have a sample size, the sample size of 5 isn't necessarily big. Size of 55 or 106 or whatever of it, and it makes your standard deviation smaller and smaller. Kind of cool to see.
Okay.
You did it, you got the z-score of 1.045, and then if you do it again with the sample size, your z-scores, because your standard deviations are smaller, proves
Okay.
it kind of thing.
Okay.
I brought the answer just to make sure you got it right, because it's your second time turning it in.
Okay. 1 second.
As mathematical as this class gets, though. Pretty soon we're going to be living on Excel, and Excel does everything for you. Correct answer, so when you do it, you can match it. And then the next question, that was number 8, right?
Yeah.
Number 9. I think this might have been the question, right? But we can figure this out. Okay, what is the probability selected students will have a mean score, excuse me, that is greater than the mean achieved by the students? Okay, so the mean achieved by them was 160, and they want it to be greater than 160. It's like the same thing as before. So if we're given the z-score, so if we're given of achieving the average greater than the average, it becomes the area that we got. Okay, sorry, my computer is taking a second. There it is. So we know the z-score is positive. D got a higher score than the average, so I put that in. And if we want to know if people can do greater than that, and she already did greater than the average, we can tell that this number is going to be pretty small. Does that make sense? She already did better than and now I want to know if people can do better than her. Score for the
It's frozen.
Uh-oh, she's frozen on my
Yeah, it's frozen. Yeah.
Man, school Wi-Fi is not up to par.
Yeah, it's not working.
Wi-Fi is not really good.
No. Rebecca, are you getting it though? With all the just disjointed talk?
No,
No.
not really.
No.
I just have to see it and do
Yeah.
it myself. But for 8, what was the answer? Is it like 2
It
point
was-
something or what
it
is
was-
it?
Just
It's
two, yeah.
2.238.
Mhm.
Okay, cool. Okay, I got it then. I just didn't do the divided by the square root of 5 or whatever.
Yeah,
Mhm.
I remember having to do that one like twice because I thought the first time around I didn't do it right, and I think it's because I had to count how many I was taking the mean from. It was I felt like it was a trick question.
Yeah, it was.
Felt like a lot of them were that way. So, and so basically
Yeah.
for 9, I just took that z-score and put it in the applet, and
Mhm.
to get the area. So if you
put
get
the
like
2.338 in the applet.
2.338, because they were wanting the probability next, and whenever it says probability, I just go straight to the applet.
Yeah.
Because that's what they're finding out. And since it's greater than, I keep the right side of the curve highlighted. And then so I put the z-score in, and let me make sure this is actually what I did. So it's
So
not,
it's like 0.0097.
yeah.
Or did I do that wrong?
0.38.
Oh, you guys got is 0.0097.
Yeah, for the
Okay, cool.
probability, because that's how I figured out how to use the applet. You know, the greater than or less than is just from the 0 of the curve, and usually that's the part I keep highlighted. So greater than is going to be the right is going to be blue, less than will, you know, the left will be blue, and that will tell you the area, and the area is the probability.
Okay.
Sweet. And also, the 14, I put 0.995.
Okay.
Yeah, I got 12 through 15 wrong. So I was doing something wrong.
Yeah.
And say I got 14 wrong, and we went over it, and she just said it was 0.995. Did you put that in, Taylor, and it was wrong?
I put that in. Like, I put that in after I put my other answer in.
Oh, okay.
Yeah. So the other time I got it wrong, but I was kind of like curious if that's what she said was 0.995.
Mhm.
Okay.
Yeah, 14 wrong.
And I got 15 wrong and 12 wrong too.
Okay.
Yeah, I was doing those wrong. I don't know what's going on.
Yeah.
Well, this was like, I don't know how pathetic this is going to make me sound, but I spent like 6 hours on this yesterday trying to figure it out because I could not like keep everything straight. And so I ended up taking pictures of the video presentation, like the slides. I just took pictures of it and then glued it into my notebook and then referred to that for like every
Kate,
question.
I am so sorry. It did,
Okay.
I don't even know.
You're good.
Anyway, so that's what I did, trying to like taking notes and trying to figure it out. Was,
Yeah.
just making sure I had the slides in my notebook.
That's smart.
Yeah, I can kind of hear something. Can y'all hear me?
Yeah, I can hear you.
Yeah, we can hear you.
I don't even know what happened. That wasn't even like a Wi-Fi thing. That just like back up. not sure when I stopped getting heard because I don't know. And so Z-score for number 8, we just put that Z-score in for number 9. Is everyone
Yeah.
greater than?
Yeah.
I don't know how far we got. Okay, sweet. I don't know if we're. And I was like
No, yeah.
explaining how we
We're
know
good.
if it's going to be small or not.
Yeah. Yeah, we just put it in the app, but we had talked about it while you were gone too. So.
Yeah.
Oh my gosh,
think
that's
I
so
get it now.
embarrassing. I was like, oh, I'm frozen. Oh, and I'm kicked off. Sorry.
But it wasn't an embarrassing picture that you were frozen in. So, I mean, there's that.
That's good.
Thank you. Because usually, you know, those are high risk.
Yeah. You weren't in like a half blink or yawn or something. You were good.
Yeah. Questions? I think Taylor, did you have any?
Yeah. So I had a question on number 12. So I don't really understand how. Yeah, I don't really understand how to do that. 12 and 15.
Okay.
So I'm really
Make it-
confused about this whole point.
Okay. Since I got kicked off and getting back on, I'm not all the way. You can just read it and I'll think about it.
All right. So it says, what is the standard deviation of distribution of the sample means, sampling distribution for the possible sample of size 81 that could be drawn from the parent population? Round your answer to the 3 decimal places, and this is shows an example. If the answer is 0.8976, then you should enter 0.898 in the answer box.
I'll open number 12 and then open up the information that comes first. Oh, one thing to say on the test, I know that rounding matters. I don't, usually like if you round in the nearest like 2 decimals and it said 3 and you got it wrong, she would probably give you points back, but like where you get to
Mm-hmm.
that was just like thought about that because when you read the question, I was like, oh yeah. So when I took this class, because I didn't round far enough. I mean,
Yeah.
he gave me the points back, but it was like, it was like, I should go through the trouble to get the points back.
Mm-hmm.
You know what I mean?
Yeah, definitely.
Okay.
Yeah.
There's like information first. And then, okay, I'm sorry. It's gonna take a.
Oh, it's fine.
Yeah, I guess I can just ask. So number 12 is referring to. Is it referring to the like the GRE test scores?
It's referring to the BYU Idaho GPA.
Okay, perfect. So I have that written down more like average is 3.5, standard deviation is 0.7. We have a sample size of 81. And number 12 is asking about the standard deviation.
Yes.
Let's see. I'm surprised no one asked about number 11. I always get those. I always trip up on number like questions like number 11. I'm like, it's too easy. Would be. Sorry. So the standard deviation gets completely. The law of large numbers teaches us that the bigger it is, the smaller standard deviation, but any sample size at all will affect it. And the reason why is because, like, in this class, because class is like super microscoped, right? And it's telling you the population's mean, or it's telling you the true average or whatever. But in the real world, we never have the true average because we can never sample every single person that's ever been born. People are hard to reach. People don't want to respond, whatever. So you can only get what you have to keep size. Deviation has to be divided by size, but we just have to screw it first. So I'm assuming these are not loaded. The answer is going to be 0.7. That's your standard deviation that's given to you, divided by this square root of 9. And you that the average, which is bogus because you never really have one, is of 81 is big enough to make it normal. And we learned that from the central limit. So the central limit people you ask, the more likely your answer is going to be normal looking, sorry. And so number 12, the formula is for you. Oh, I'm sorry, I wrote the wrong deviation. So this is your answer. Can you see that? I can rewrite it. I feel like I wrote it really badly.
It's got a little hard to see. It doesn't seem put all the calculations in right.
So it's your standard deviation.
Uh-huh.
Square root of the sample size. 81 happens to be a clean number, which is nice. So it's 0.7, which is the number you're given. 9, and that equals 0.07777 continued to 0.078 is your correct answer.
Sweet. Awesome. That helped a lot with that question.
Good. And I hope that clarifies the difference between central limit theorem and law of large numbers, because that kind of question, like every test, it's going to give you a scenario and be like, all those.
She freeze again. Dang.
Yeah. Dang it.
Almost.
I can still hear y'all. Can y'all still hear me?
Yeah, I can hear you. Yeah.
There we go.
Good.
So frozen.
She was waking up a lot. So.
Sorry. Okay, number 15, right? Oops. Number 15, let's write what we know. We have n equals 48. Standard deviation is 26.7. Is 185. And the x bar is 177.6. And we want to find that a random sample of passengers will have a weight that is as extreme or more extreme. Okay. So I'm pretty sure I didn't get to before I met with you, just because I was like, oh, I got this. I didn't do number 15 yet. But extreme or more extreme, it's just going to be the z-score.
Oh, really?
Bros.
Do we know?
What?
We couldn't hear anything.
Can you hear me now?
Yes.
Okay. Score formula is it's x bar minus x divided by divided by greater than. Okay, so we know x bar is 177.6. E is 185. Well, if the z-score is going to be positive or negative. Do we know?
Negative. Would it be
It's less
negative?
than.
Mhm.
That's going to be important. I'm just making sure that we can catch that as fast as possible, because that's like half the battle, half the time on these questions.
Uh-huh.
9.6 minus 185 equals 7.4, and it has to stay negative. We can't just like take the negative away. 26 point, oh, hold on, is calculator, so I have to do it in weird order. 26.7 divided by 6.928. So what did you get for your denominator? Your bottom of the fraction.
Just trying to figure it out. Once.
So it's 26.7 divided by the square root of 48. So we do the square root first. The square root.
So my calculator's not really acting on me. I got 8.814, but that's probably wrong.
Okay, so what did you do? What did you put in your calculator? Let's figure out where it went wrong.
So I put, like you said, like negative 7.4, is that correct? And I put like the square root of, let me see.
So negative 7.4 was your x bar minus x. That's going to stay up top for a second.
Okay. Okay, that's.
So you just leave that there, write that down so you have it written down. Now we're doing the bottom of the fraction, which is divided by square root of 48. The reason I say to leave it there is because of the calculator. If the calculator is a little bit smarter, you could just put it in. But for the sake of not making mistakes, I would just do the top and calculate the bottom, write it down, and then divide the top from the bottom.
Oh, okay.
I don't know what kind of calculator you have, but some graphing calculators, if you put enough parentheses, you can probably make it work. But that just gets really sticky. Like I have a really simple calculator, so I have to just write things down and then. So you're not doing it necessarily wrong. It just depends on your calculator.
Yeah.
Okay, so what did you get for the square root of 48?
So my calculator, so I don't have it with me right now. I left it on campus. So I'm using my phone.
No.
So I was like, yeah, I'm trying to see if they have like a square root button, but I don't see it.
Okay. Here, I'll tell you the square root is. The square root of 48 is approximately 6.9282. To go. 6.9282.
Okay, and that's the square root of 48 of this equation.
Yep. And so now we need to do 26.7 divided by that.
26.7?
That's your standard deviation. You said 26.7 divided by 6.9282. Oh man. I hope you get your calculator back.
Yeah, I hope so too, because like I was using it, like I spent like a long time the homework and everything yesterday with the calculator, and then I like totally forgot it at the tutoring center. And so I need to pick it up today.
People are really good about putting lots of stuff back.
Yeah, definitely.
Phone and got it back. So that phone is a really nice one, but people are good here.
Yeah, people are for sure. So I divided, so I put 6.9282 divided by 26.7, and that gave me 3.8538.
Perfect. So that's now the bottom of the fraction. So now you're this far. right?
Well, let me see real quick.
You
Yeah.
just figured out this number.
Yes.
Done it. Right. Okay. You did it right. 0.4 divided by that.
Just 7.4, not negative.
Sorry, negative 7.4. Sorry.
Oh.
I did it right, but I didn't say it out loud right. 3.85. 1.92. And negative 1.92, right? Square. So now we go to the applet. So you did step 1 correct. But now we got to do step 2.
I'm going to the applet right now.
It's because of the Wi-Fi here. If you Google just the word normal probability applet's like the first thing that they assume you mean.
So would I put 1.92 where it says area?
Z-score. So the formula that we use is
Oh yeah, this is Z-score on the very bottom.
Yeah.
Okay.
Yeah, for the Z-score. Question is as extreme or extreme, and that's a weird way of saying it. What that means: less than 92 Z-score or greater than tails, if that makes any sense.
Mm-hmm.
So I would
Makes sense.
highlight the left tail and the right tail, and that is your answer.
So that gave me 0.0549.
And then it wants you to round the nearest 3 places, so it's 0.055.
Sweet. That helped out a lot.
I know that this class is like people who like avoided math in their major, and this is like the math class they make you take. So like math is not everybody's thing. Like I understand. I don't like other subjects. So and I know like this is like all foreign stuff that we've never learned in our lives. So as extreme or sorry, how did it word it? Just so we can like look at it one more time. As extreme or more extreme, you're not only interested in values lower than the ones we observed, but means as far away as possible, and the means is a positive direction. So that's telling us it's the tails on the test. On the test, all of y'all only missed like 1 or 2, which isn't that many at all. Can y'all still hear me?
Yes.
Yes, sorry about that.
Good. I was like, I don't know if I'm frozen. All right. Is there any other like objective questions? That's not the right word. Conceptual questions at all?
No, I'm good.
Good.
I think you're in my Get Connected group freshman year.
What? What'd you
I
say?
Get Connected group freshman year.
Yeah, I totally think. Okay. When you got on, I was like, you look so familiar. Megan? Yeah, okay. Yep, I know who you are.
Perfect memory. So I like remember you, but like I don't know if people remember me as well because it was like a long time ago. So every time I see you on campus, like somebody see me on campus, like I like don't say anything. I'm like, I don't think people remember me. I have a really creepy memory though. Like I remember people's names for like years. So like I totally kind of know you.
Oh yeah, I remember right when you got on, I'm like, oh, she looks like that girl. Like I know who she is. And then when you start talking, I'm like, oh,
Yeah.
not her.
Yeah.
I don't know. Cool.
I was like, I might as well make the connection now. Next time I see you in person, I'll just say hi.
Cool.
Y'all did awesome, and feel free to email me anytime. Talk with them like a day. Any questions? Like people would email me questions on quizzes they got wrong, and I like type out how to do it. So.
Okay.
Oh, sweet.
Thank you.
Thank you so much.
Perfect. Yeah, and good luck on the first test. I know it's sort of coming up, so.
Yeah.
Yeah.
Thank you.
All right. Have a great day.
You too. Have a great one. Bye.